to question number 7 from the 2014 examination paper. So 7 part A, we want to write a MATLAB program which plots an F-alpha curve. Here is the formula for alpha, here is the formula for F. And question 7B, we want to sketch a phase portrait for this 3-dimensional linear system. So for 7 part A, if you look in the notes, I've given you a MATLAB program. Here is the MATLAB program written in by hand, and this is what you would have to write in your answer booklet. So you have to write the MATLAB code in your answer book. So we put K is 500, P1 is sim, 0.1 is 1/10, and 9/10 is 0.9. S goes from 0 to 500, so that's from this formula here. S is our parameter. AS, well, instead of alpha S, I've put AS. So you can see we've got the formula S times log P1 plus K minus S log P2 all over minus K log 3 is the same as K log of 1/3. And here's the formula for FS. So to work out this formula, I've got it here. So for I is 1 to length of S, so S is our parameter. Here is the formula for FS. And you can see the K choose S here is the N choose K. So this is how we do K choose S in MATLAB. And then to plot, we plot AS against FS to get the F-alpha curve. Now again, in your answer booklet, you have to do a sketch. So if we run this program in MATLAB and then we use the data cursor, we can see where the F-alpha curve crosses the alpha axis. And we also know that there's a maximum when X is 1.084, I think that is, and 0.625. So you should clearly label these graphs. What information does the local maximum give? So the local maximum here gives a measure of density. So how densely does the fractal cover the object? So here is the fractal dimension, which is 0.625. So that gives us a measure of density in physical applications. For 7 part B, we have this 3-dimensional linear system which can be uncoupled. So you can see we can look at this in the YZ plane. In the YZ plane, again you use MATLAB on this matrix and we get the eigenvalues here. Because the real part is negative, this is a stable focus, and you can plot the isoclines which I've shown here. So here is the stable focus in the YZ plane. And then this is where you have to use your artistry. You can see I've done a rough sketch here. So X, Y, Z is a 3-dimensional picture. Remember, we have a stable focus in the YZ plane. Because X dot is negative, trajectories spiral towards the origin. So on this half, they spiral in towards the origin here. And from the back, the trajectories spiral again towards the origin. So the flow is on what I consider kind of a Diablo. So this is like a Diablo, and you can see that the origin is stable. So that concludes the solutions to question number 7.